Basics of Gait Part 1. In this video series, I will attempt both to simplify and expand on the neuroanatomical underpinnings of gait. This is in no way an exhaustive discussion and is instead designed to break down some of the more complex aspects of neuroanatomy into a more easily digestible format. The voice you hear is AI generated, but the content of the video was compiled and edited by Dr. Javier Suarez, a movement disorders fellow neurologist at the University of Minnesota, with the use of the Synthesia software platform. Human bipedalism is unique in the animal kingdom, requiring a precise and constant series of movements to maintain an upright posture. Indeed, no other animal uses habitual orthograde posture and locomotion using harmonic cycles of anatomical pendulums for ambulation. As you saw in the previous clips, humans are not the only bipedal animals. Birds, of course, are exclusively bipedal, and they can all walk, but they do not walk like humans. Their body plans are markedly distinct and specialized for multiple forms of locomotion. What about ostriches, emus, cassowaries? While these birds do walk on 2 feet as their only means of locomotion, their bodies and feet are shaped very differently to a human. The bend in their knees, long necks, different orientation of the hip, to name just a few, all play a role in helping them keep their balance in a different way than humans. This type of comparative anatomy and evolution are dense topics in themselves, and you will find more complete analyses linked in the description. Let's move to an overview of human gait in action. Gait is typically broken down into discrete phases based on the position of the feet with relation to each other and the center of gravity. The video shown here is from Dr. Kevin Kirby, DPM. Link in the description for his full video and commentary. The main takeaway for our purposes is to appreciate the sheer difficulty of human bipedalism, as it requires maintenance of balance with one foot on the ground at a given time with a very small window for the center of gravity before it leads to falling over if postural corrections are not made. To further illustrate this point, think of a plastic doll modeled after a human. If you have ever tried to make them stand on their own, you would find it is supremely difficult, and any perturbation would make them topple over unless they adopt a very wide stance or have particularly large feet. This is why we do not make tables or chairs with 2 legs. Maintenance of posture and balance in human bipedalism requires muscle contractions throughout the back, torso, legs, and arms in concert, and it is achieved almost entirely unconsciously. This concludes Part 1. In Part 2, we will break down the 2 requirements for gait production: equilibrium and locomotion. We will begin to explore the neuroanatomy of gait as well. In Part 3, we dive into the concept of a desired postural state and an internal postural schema and explore the sensory inputs that modulate gait. We end with Part 4, where we explore descending pathways that lead to postural adjustments. I hope this series serves as a foundation for your exploration of gait neurology. I recommend watching this series first, then moving to Dr. Ed Miyawaki and team's Lessons from Unusual Gaits, which is also linked in the description.